Alright guys, how we doing? Welcome back to another video. So I've been playing around with AI and I've been having a lot of fun. As you know, this is my training rig or my kind of PLC setup rig that I've got, where I've got a little e-stop, little reset button, PLC, Siemens 1200, Arduino, a PC, a tablet to stream the PC, where I've got my own little Electron JS HMI running on there, which, you know, I've done all a video about all of these things. So what I haven't done a video on this rig, and what I wanted to do for a long time, is this cheeky Raspberry Pi. So obviously this is a 24-volt rig, and I've got a little what's it called, a 24-volt to 5-volt boost buck converter. So DC to DC converter, dropping my 24 down to 5 volts, and then that then powers my Raspberry Pi here. And then now what I've got is I've got Google's Gemma 3, so their Gemma 3 1 billion parameter model running on this Raspberry Pi. And what I'm doing is I'm using Snap7, which is a Python library, to read the I/O on this PLC. So every time I hit the stop, and every time, you know, you can see that I've got my status LED changing color depending on the status of the e-stop. So now it's green. Yeah. So depending on what I do, as I change my I/O here, whatever I'm doing on my test rig, I've got it being logged. So I've got two different Snap7 programs here, right? I've got one on this PC, which is an Electron JS app, and that's looking at all of this I/O here. So on my screen here, I can control the PLC. Likewise, I'm sending all that data over Snap7 over to my Pi, and then the Pi is reading it. And if I show you over here, this is just a screen that's connected to my Pi, yeah? So here's the app that I've made, and I've called it e-stop AI status reporter. And essentially what this does is it looks at all my I/O that I've got in here, so my inputs and outputs. So there I've got, for example, my emergency stop, and you can see that's on. Maybe I can zoom in here. Yeah. So safety system and emergency stop is on. If I hit the stop, this is kind of basic stuff. Takes a little while, and then it displays on there that the system's not healthy. There you go. Cool. Pretty simple here. Then what I can do now is, because I've got this Raspberry Pi running, so it is running currently the Gemma 3 1 billion parameter model via Ollama. What I can do is, on the dashboard, I can come down here and I can type in questions. So I can say what caused most recent e-stop, how many e-stops have we had today, has anyone touched this red button today, has anyone touched the green button today, and it will produce a report for me and tell me yes or no something's happened, right? Now that works, and that works pretty well. What's really cool now is if I go to reports, every 15 minutes, so the one's just been produced right now, every 15 minutes, I've got it producing a full report for me, where I basically take 100 of the latest I/O events, and I save that to a JSON file, and then I send that to the Ollama model running underneath. So if I click on my Ollama model here, Ollama monitor, you will then see it's currently online. I think the model status is loading, which means it might be running something. Okay. It's generating a report right now. Cool. So I send over 206% CPU usage. Bloody hell. So my Raspberry Pi is getting hot right now. Yeah, it's boiling. All right. So I send over all that I/O data over to Ollama, and then what it does is I'll show you actually. I send over the I/O data, and then I also send over a system prompt. Here's the system prompt that I send over. I say, you are an industrial automation AI assistant tasked with producing a comprehensive report on what has occurred on this PLC test machine during the last set interval time minutes. And so I've got my interval time here, which is currently 15 minutes. I can change it to whatever I want. And then I say, so some context, this is a Siemens S7-1200 PLC controlling a test rig with safety systems. Emergency stop functionality is present and critical for safety. System includes buttons, switches, LEDs, analog inputs, and spare I/O. Force values indicate manual overrides that may mask true process states. So I've got some forcing involved in this rig here, yeah? I then send over the recent events, and I say, Please provide a clear, professional operator report focusing on what actually happened during this period, current system status and safety condition, any anomalies or items requiring attention, and then operational insights for the test rig. And then my thought process here is that I could stick this Raspberry Pi now on any PLC rig, just stick it in a panel anywhere, and then have it produce reports on that rig and tell me exactly what's happening or on that machine. And that's just pretty cool. So if I come over here to reports, and then yeah, here's my first report, another report. So I've got one report, and so I don't know why it's not quite 15 minutes. I think sometimes some reports take, depending on the amount of IO and what's happened in that time, some reports take 5-10 minutes to generate, some reports take 2 minutes. So I've got one report here at 4:29, another report at 4:20, and then I was playing about a bit before this, and it's like 1:45 was my previous report. So if we read, let's read this 4:20 report. Okay, here's a concise technical analysis report based on the provided PLC data, focusing on the key observations. Technical analysis will support the last 15 minutes. The PLC system experienced a period of relatively quiet operation. I think I was in the shower at the time. With 0 to 29 signals online. Emergency stop functionality remained active, indicating a critical safety state. There were no errors or false values detected during this time. The system showed no significant operation changes. Cool. And then I've come and I've used my rig. And so the next report after this was during the last 15 minutes, the PLC experienced a period of relatively quiet operation. Okay, with online. So I need to fix that. It looks like there's an issue with how many signals are online. The emergency stop was actively engaged, indicating a critical safety state. A significant number of events occurred, including, and then it says, it highlights 2 events. These represent a high volume of manual overrides that may mask true process states. The system shows a consistent state of normal operation with no immediate anomalies. Okay, if we go to another report, so depending on what, if I'm actually doing anything on the rig, obviously. So the system continues stable operation with 36 total signals, 36 online, and 0 errors. Recent events show HMI clear forcing activation. Suggests routine clearing of any potential forcing conditions. The e-stop monitoring, so this shows, and it knows that I've pressed on here. So on my HMI here, I've got a clear forcing button. So I can hit that. And then that will, if any of my IO has been forced, it will clear the forcing. So that's currently true. And then I can fault reset as well. So that will, this has obviously seen that I've pressed that at some point just before I started recording the video. So the e-stop monitoring system remains in normal operation state with no emergency conditions detected. It's likely routine HMI maintenance was performed with HMI clear forcing ensuring no unwanted force states remain active. So yeah, the plan here, if I go back to an older one then, I don't know, let's pick weird one. Okay, here. So this one's slightly different, and this is the cool thing because it said it's just generating it from a prompt, and I'm not really giving it any set format. The format changes prompt to prompt, so the reports kind of change prompt to prompt, which is pretty interesting. So summary: the PLC system continues in controlled operation with 36 on the line, 0 errors. Recent events show left switch state transitioning, likely during routine testing. So it shows that I pressed this switch and turn it left. Cool. All right, so I don't want to drag this on anymore. I'll quickly, all of this is on my GitHub, so you can just go on my GitHub and download all of this, and you're free to use it as well. So just trying to see if okay, so I guess the only thing that I haven't covered really is that this is a PWA app, so it's a progressive web app. It's kind of basically instead of using Electron.js, which is what I've used on my HMI over there, this app is just a Python web app. It's pretty simple. Yeah, I think I've pretty much covered everything. So it's a Flask app that I'm using. This is just what makes it pretty, and it kind of handles a lot of the back-end comms stuff. I'm running Gemma 3. Okay, I guess the only thing I can mention to you is the model I'm using is Gemma 3 1 billion parameter. Now I could change to their new 270 million parameter model, and I did try it, but the reports basically didn't make sense. There wasn't enough, the model didn't have enough juice basically to make stuff that made sense. So that's why I've gone with the more beefier model. But if I was to replace now this Pi and instead go with, so instead of running the Pi, if I went with a Jetson Nano, I'd get much more capability and I could run a much larger model, and then my reports would be much better as well. So yeah, I think that's it from me. Okay, next steps. So right now I'm sending everything over Snap7 and it's pretty slow. It does miss some events. So for example, if I just press this button like that now, that event probably didn't get recorded. So what I've done in the past is I've ran a SQL server on my PLC. Sorry, I've run a SQL server on my PC, and then you can use a library or a function in Tier Portal and write to that SQL server direct from the PLC. And that you can write at, like, I think the fastest I ever got to was 10 milliseconds, which is insanely fast. Like, you're not going to miss almost anything there. So I was thinking is maybe I data log everything from the PLC to the SQL server on my PC, and then have the Pi or the PC, whichever one I want. I wanted to use the Pi because it's only 50 quid, whilst this is like 150 quid. But yeah, then I can have the app and run the AI model locally on my PC or on my Pi and have it read the SQL server, and then you'd be getting proper accurate information. So yeah, that's what I might do next. Cool. If you like it, let me know. I think this has a lot of potential, really. Running models locally on your machine to produce reports for maintenance or for operators or even for engineers. Like if I just had a report running on the background, just seeing what's going on and summarizing all the operators' button presses, when they ring me and say, Hamed, you know, it ain't working, your system's not working, I can be like, well, hang on a minute, mate. I can see here you've pressed the force reset button 6 times. What's going on? Do you know what I mean? Yeah, something like that. All right, cool. Thanks for watching, guys. I'll see you in the next one. Take care. Bye-bye.